So, in today's video, we are going to discuss breadth search technique in artificial intelligence. So, in this video, we are going to discuss all the key points and important points regarding it, which will be helpful in your comparative exam. Um, in case of BFS, we know that BFS come from ununiform search techniques. You can call it in case of uninformed such technique, because in case of uninformed such technique, we do not have um, how much space it will take, how much from the goal node to the starting node, how much distance we have to travel. So those type of information we do not get from the uninformed such techniques. So that is why it's also called blind technique. Also, you can call this is a brute force method. So even why it is called brute force method? Because in case of brute force method, you can definitely get one solution over that particular problem. Um, uh, what is the meaning of uninformed over here? There is no domain. I already said that there is no domain specific knowledge in comparison to this. So what do we have? We have heuristic techniques. What happens in heuristic technique? We can take an estimate value, we can take an estimate value that if I want to go on goal state from any particular state, then how much cost will it incur? But over here, we do not any prior knowledge like heuristic. What we do in heuristic, let's say if I went from A to B, like this graph, A to B, um, what is the cost to go from B to the go state? Suppose the go state is G. So then over here, the cost to go from A to B, and what is the cost to go from B to the go state? Know this thing in advance only. So that is why the heuristics method helped us. It already given us the cost to reach that particular node to the goal node. Okay. Um, so that's how we have to go from A to B. What we know, what will be the cost from A to B. But now B taking me to goal state, suppose. So it is not taking me how much is the cost. How much cost is not here in BFS or uninformed search algorithm. Um, so there is no information regarding, so that is why we can call uniform search or blind search. The meaning of blind search is I don't know when I will get the goal state, but I know that someday I will get the goal state. So that is why we call this is as uninformed search technique. Okay. So the BFS is belongs to inform such technique. The next point is FIFO. FIFO means first in, first out. So, which data structure does it use? Q. So, by default, keywords on FIFO on the basis of this graph over here we have taken in our slides here. You can take tree, also you can take graph, any of them. Also, so if we apply BFS on this, so we how we have to work over here. So as we have written over here, we'll be using Q data structure. So first of all, you should know in Q that we always insert element in Q from tail and we remove elements from here. That means first in and that only will the first out. So if we talk first of all which element will come over here. So A is the first element which will come first, and so we added A over here. It is it used at a lot of place. So first of all, firing the first node. We use a lot of keywords over here. You remember with a simple method, because only two types of question will come. Either you will be given a graph or you will given a tree. On that it can be asked that in this a proper BFS or not, or a theory points related to this which have which we have written over here. It can be asked about that. So if over here we talk about A, if we removed A from the queue, so what is the meaning of removing A from the queue? So A is taking us ahead at how many places from A where all we can go. First, we have added those elements over here. So, which are the elements? So, you can see B, C, D. You can write this in any order. It is not necessary that you write B, C, D only. You can write also C, D, B, or you can write also D, C, B, whatever it is. If anyway, but if you will follow one pattern, then you will come to know you can also use some other BFS search. Any other pattern also can be formed, but we'll come to know about one technique over here. So we removed A from the queue, and after we saw, and after we saw, and uh, and after we saw that, um, after after we saw that, um, that uh, taking us at how many places? That means B, C, and D. So we added them in the queue. We added them in the queue. Now what we did is remove B, because first we added A, then added remove A, then we added B, C, D. So first we remove B from here. Okay. So we remove B from the queue, and B is taking us at how many places that we insert. Show B is taking us at E and F respectively. So this is by default. So this is by default. Um, the, so this is by a default queue. Only if you want, you can make this like queue. But as I told, insertion is always to be done from behind, and we remove the value from head, which is the rule of first in and first out. So now we removed C from here. So where C can take us, G and H, then C will be removed. Then D is added. Where D has take us, I. Okay. So after B, C, D removed, we have the element which is added in the next queue, E, F, G, H, I respectively. So then E is removed from the queue, where E is taking us J and K respectively. Then we removed F. If F is taking us anything, no. So here we can see that um, no, we can see that F is not taking us any Q. But as I told, insertion is always to be done from behind. We remove the value from head, which is the rule of first in, first out. So now we have removed C from here. So where C is taking us, C can take us to G and H. So we inserted G and H from tail. So in this way, we just have to keep on going. Then we remove D from here. The meaning of removing D is we already element E, F, G, H in the queue. But the meaning of removing D is where is D taking us? It is taking us on I. So what we have written over here, we have inserted I from tail. So over here, what knowledge do you get? We are getting the knowledge shallowest node. The meaning of the shallowest node is if we talk about the DFS in comparison to the to depth search. So how does DFS work? It goes in one direction and goes in deep and goes till complete depth. But BFS does not do like this DFS. So BFS goes level by level, level by level. So you can also call this as level order. This is also called label search technique. Why? First of all, we want on this level. Now we are on this level. So we have complete this whole level. Then suppose see first we remove B, then C, now D. So when D level is removed, this whole level is completed. Now we came on the next level. That means instead of in deep, it completes the salvage node, the nearest node. In this, we'll remove head level wise level. So this knowledge is the most important key point in BFS. And this is only as the most. So you have to remember only these important points over here. So now we remove D, which is the next element is E. So now we remove E. Now what is insert? Now, what is in formed here? F, G, H, I, and where is taking E taking us? E is taking us at J and K. So we insert J, K from tail, and that is now we will remove F, then J, H, I, J, K, and where F is taking us? It is not taking us anywhere. That means it does not have any children ahead of A. So keep it as it. Then we remove G from here. So what is formed? HI, JK is already the Q. And where is G taking us? It is taking us to level L or L. Okay. So which have so tell again we are going on which level we are going on this level. After complete the whole level, it will go to the next level. Then if we remove the age from here, IJKL, what do we have over here after L, which we have cut? That is age. Where is age taking us? It is not taking us anywhere. So let it be written as it is. Then we removed I from here. Then J, K, L, and I is taking us at M. Then what is the next that will write M? Now we see next which level is finished. This whole level is now complete because we complete E, F, G, H, I also. So now the next level is J, K, L, M. So now it's the time to remove J. So where is J taking us? Now here, so the next level, so the next we will remove K because J is um, taking us nowhere. Okay, so the next level is K. So after removing K, then L and M is left because the K is taking us to the level N. So after that, L and M, say L is taking us anywhere? No. M is taking us anywhere? No. So now L and M remove respectively. So what is the remaining? Remaining is N. So N is left, so it moves in this way and it moves level by level only. So that means order instead of going in deep, it moves like this level by level. So if you want to search any element, then then will this give answer? Will this definitely search an element? Yes. Why? Because we are not leaving any element behind in this. What we do in DFS, we move one direction, we are going in one depth, other elements is upper depth, okay, are kept in as it is. The one which I wanted to search, that is in the above level, but we are going in one depth, like A, B, E, like that. But our goal state suppose N. So we do not move on the next higher level. Okay. So in that particular case in DFS, because it move in one direction, sometime we might be get stuck in any loop. And if the search page we are stuck is infinite, then we will never be able to search the element. But instead of BFS, we talk about BFS base first. As such, it is completing all the labels one by one or successive node one by one in this way. So we can say that will definitely it will give an answer. That is why we tell over here complete. What is the meaning of complete? This will definitely give an answer. It is not complete. That means if you search any element, even if you are searching G, so search G, you will go in this way only as you got G element. Let's say over here you had found G element. So when you are going on the on and then over here you had formed G element. So before cutting G element, you check that is G element ghosted. Ghosted means in this the element that we are searching. Yes, it is element. So what happens? We take its parent node pointer. Then who is the parent of G? C. And who is the parent of C? That is A. So in this way, ACG, we define the path. So this is when we want to search any particular element. But if we want to see all of them, then run press first in this way. So we have the optimal solution, which is already maintained. So what is the meaning of optimal? We have breadth first search. Does this give optimal result? Does this gives a shortest result? Yes, it will always give you the shortest result. And all the nodes, all the age that we have, the cost of age will be same. So that means it will give shortest cost. And in case if you are giving its cost different, also then um, it will give the shortest path only. So it is always gives optimum result only. And the last point we have time complexity. So we know that the kind of time complexity is the order of b to the power b, where b is the uh, branching factor and d is the depth of the d is the depth. So that's all for the BFS. Thank you.